Hello children, this is area and perimeter of plane figures or two-dimensional mensuration part 4 based on quadrilaterals. Okay. In part 3 I have already explained the formulas to find area and perimeter of different types of quadrilaterals. In this part I will be simply solving different types of examples. Okay. So you can open your book at page number 254, 254, exercise 20B. Exercise 20B. Okay. Exercise 20B. Exercise 20B. Ready? Question number 1. Question number 1. Find the area of a quadrilateral, one of whose diagonals is 30 cm long. Okay. One of whose diagonals is 30 cm long. So B is equal to 30 cm. And the perpendiculars from other two vertices are 19 cm and 11 cm respectively. So let the perpendiculars be P1 and P2. They are 19 cm and 11 cm respectively. So area will be, we know, if one diagonal is given and two perpendiculars are given on that diagonal from the remaining two vertices, area is equal to half into B into P1 plus P2. So 1 by 2 into 30 into P1 plus P2 means 19 plus 11, that is again 30. So this will be 450 square cm. Okay, so area of the quadrilateral is 450 square cm. Question number 2. Question number 2. The diagonals of a quadrilateral are 16 cm and 13 cm. Okay. If they intersect each other at right angle, very good. Okay. The diagonals are perpendicular to each other. So D1 is equal to 16 cm. D2 is equal to 13 cm. Area is equal to, in such a case, half into D1 into D2, because the diagonals are perpendicular to each other. 1 by 2 into 16 into 13, 2 into 8 is 16, so 104 square cm. 8 into 13 is 104 square cm. Okay. Next, question number 6. Question number 6. Question number question number 8. Okay, question number 8. How many tiles each of area 400 square cm will be needed to pave a footpath which is 2 meter wide and surrounds a grass plot 25 meter long and 13 meter wide? So we have a rectangular grass plot like this. We have a rectangular grass plot like this. This is 25 meter and this is 13 meter. Okay. Then there is a footpath running all around the outside the grass plot, whose width is 2 meter. Uniform width is 2 meter. Suppose this is the footpath. This is the footpath. Okay. And this is 2 meter. Here also 2 meter, 2 meter, 2 meter. Okay. This is the footpath. This is the footpath. Okay. First we need to find the area of the footpath. Now how to find area of the footpath? See, there are two rectangles here. One is inner rectangle, the other is outer rectangle. And area of this shaded portion or area of the footpath is equal to difference between the area of the two rectangles. Inner rectangle length is 25 meter, breadth is 13 meter. You can see it is given in the question. Outer rectangle length is, this is 25, this is 2, this is 2. So 25 plus 4 is 29 meter. Okay. Now breadth of this outer rectangle is equal to, this is 13, 2, 2. So 13 plus 4, that is 17 meter. So area of the footpath is equal to area of the outer rectangle minus area of the inner rectangle. Okay. So area of footpath is equal to LB minus LB. Means area of outer rectangle minus area of inner rectangle. Okay. So 29 into 17 minus 25 into 13. Okay. This is 17,351, 510 minus 17, 490, 493. 25 into 13. 325. So this is equal to, how much it is? 175, 165, 168. 168 square meter. Okay. So area of the footpath is equal to 168 square meter. Ready? Now this is one method. Okay. There is another method, that is soft trick for this. Okay. Although many students are not able to memorize that formula, still I am giving this. Okay. You don't need to do like this. Directly using the formula you will get 168 square meter. See the formula. Area of footpath is equal to 2x L plus B plus 2x. Okay. Here L is length, B is breadth, x is width of the footpath. Now see, the footpath is outside the rectangle. Okay. If I erase this, okay, this is another method. The footpath is outside the rectangle, outside the plot. So when the footpath is outside the plot, you have to put plus sign here plus sign. If the footpath would be inside, means the footpath would be here. Okay, the footpath would be inside the rectangular plot, then you would have put here minus. The formula would have been L plus B minus 2x. So there is very little difference between the two formulas. If footpath is outside, then plus. If footpath is inside, then minus. Okay, here footpath is outside, so I have put plus. So that is equal to x in width, which is 2, length is 25, breadth is 13, again 2x is 2 into 2, 4. Ready? 4 into, what is this? 25 plus 13 is 35, 38, 42. 4 into 42 is 168 square meter. Same value we are getting. Okay. So there are two methods. This method gives you the answer faster, but you have to memorize the formula. If you are not able to memorize, then use the previous method. So area of the footpath is 168 square meter. And this footpath has to be covered with square tiles, whose area is given 400 square cm. So there is difference in the unit. The area of the footpath we have got in square meter. The area of the square tiles is given in square cm. So let us convert this square meter into square cm. Okay. Now you know that 1 meter is equal to 100 cm. Okay. So definitely 1 square meter will be square of this. That is 10,000 square cm. Okay. Similarly, 1 cubic meter will be cube of 100. Okay, so there will be 60 cubic cm. Okay. So that is equal to 16840 square cm. So here comma, here comma. International system. If you use the international system, 1,680,000 square cm. Okay. Now let us see how many tiles will be required. Now we have to use unitary method. Number of tiles you have to find. (400 square cm is the area of one tile. Okay. So how many tiles will be required for covering this much area? 1,680,000 square cm. This is unitary method. Okay. 400 square cm is the area of one tile. 1 square cm is the area of 1 by 400 tiles. Okay. 168 square cm is the area of 1 by 400 into 168 times 0000 cancel 4 4 2 00 tiles. So how many tiles will be required? Exactly 4,200 tiles will be required to cover the footpath. Okay. This is question number 8. Now let us move to question number 13. Okay, question number 13. The rate for a 1.20 meter wide carpet you have seen, that of fixed width, and the length you have to decide. Okay, in order to cover a room, okay, you have to decide the length. So the width of the carpet is 1.20 meter and rate is rupees 40 per meter. Per meter the rate is rupees 40. Find the cost of covering a hall 45 meter long. Length is 45 meter. Breadth is 32 meters. Okay, we have to cover the floor of that room using the carpet. Now, carpet of this side will not be available. Means whose length will be 45 meter, whose breadth will be 32 meter. Such a carpet will not be available. So what you have to do? You have to bring a very long carpet. Okay, and depending on the length or breadth, okay, you have to cut the carpet into equal pieces and you have to cover the floor. That you can do. Okay, so imagine a scenario. You have covered the floor of a room with the help of a carpet. Okay, by cutting it into different pieces. So can I say area of the floor is equal to total area of the carpet? Okay, we can say area of the floor is equal to area of the total area of the carpet. Okay, so use this formula. Total area of carpet is equal to area of floor. Okay. Now you can see the length of carpet. Suppose let it be L1. Sorry. Breadth of carpet is given. Sorry. Breadth is given D1. Suppose is 1.2 meter. Okay. 1.2 means approximately this wide. This wide. Okay. So this is the width of the carpet. Length we have to find. The floor is in the shape of a rectangle. The floor of every room is in the shape of a rectangle. The carpet is also in the shape of a rectangle. Okay. So two rectangles we are going to equate. Okay. Two rectangles area we are going to equate. Area of carpet which is in the shape of rectangle is equal to area of the floor which is also in the shape of a rectangle. So L1 into B1 is equal to L into B. Now let us put values. L1 we don't know. B1 is 1.2, L is 45, B is 32. So L sorry, L1 is equal to 45 into 32. Now 1.2 means 12 by 10. So if it goes this side, it will become 10 by 12. Okay, 10 by 12. Let us simplify this. 4 3s are 12, 4 is 32, 3 15s are 45. 15 into 8 is equal to 120. So total length of the carpet that is required to cover the floor of that room, if dimensions are given, is 1200 meter. Okay. So this is the length of the carpet required. But we have been asked to find the cost of the carpet. Okay. So cost, rate is also given. Okay. Rate is also given. Rupees 40 per meter. Okay. Rupees 40 per meter. This is given. Okay. So we can easily find the rate, means total cost of the carpet. Cost of carpet is equal to 1 meter cost rupees 40. So 1200 meter will cost 1200 into 40, that is 48,000 rupees. Okay. So cost of carpet is equal to rupees 48,000. Now one more case has been given. Also find the cost of carpeting the same home, the same area. Okay. Dimension same, 45 32, but in this case the the width of carpet is not the previous one, it is now 80 cm. Okay, so if you change values, rate is also different. Now breadth is 80 cm or 0.8 meter. Okay, so give importance to units. All the units should be same. Okay, here everything is in meter, length, breadth, so I converted same into meter. Okay, rate is also given in per meter. Okay, so either convert everything to cm or convert everything to meter. Okay, so breadth is 0.8 meter, length we don't know. What is the rate? Rupees 25 per meter. Rupees 25 per meter. Now again let us find the length of the carpet required. L1 B1 is equal to LB. Area, total area of carpet equal to total area of the floor. Okay. So L1 into 0.8 is equal to 45 into 32. Okay. So L1 is equal to 45 into 32 into 10 by 8, 8 4 32. 35 into 4, 180 meters. Okay, so in this case the length of the carpet will be 1800 meter. Why? Because you can see the breadth has been decreased. Initially the breadth was in the first case the breadth was 1.2 meter. Here the breadth is 0.2 meter. So when breadth is decreased, definitely the length has to be increased in order to maintain the same area. Okay, so we got the length, then we will find the cost. Rupees 25 per meter. Okay, so cost is equal to 1800 into 25, which is 18 into 25 means 450 rupees 45,000. So this carpet is cheaper than the previous one. Okay, so this is question number 13. Next question number 14. Question number 14. Find the area and perimeter of a square plot of land. Number 14. Okay. Square plot of a land, length of whose diagonal is given 15 meters. Okay. The diagonal of the square is 15 meters. We have to find area of the square plot. Okay. We know area is equal to area of the square is a square if side is given, or half d square if diagonal is given. Okay, so we can use the formula related to diagonal half d square. 1 by 2 into d square means 15 square, which is 2 to 5. So 2 to 5 by 2 means 112.5 square meter. Okay, area is equal to 112.5 square meter. This is the area of a square curve. Next, perimeter also you have to find. Give your answer correct to two places of decimal. Okay. In order to find perimeter, we are bound to move to side. Anyhow, we need the side. So how to get the side? There was a relation between diagonal and side. D is equal to root 2a. Okay, D is equal to root 2a. Okay, I have remembered, means I got suddenly, so I have written this. Okay, I had given this in part 3. Okay, so if you are not able to remember this, no problem. Okay, then every time that you will forget this formula because it is very less used. Okay, the thing that we use the most that remains in our memory by repeating. Okay, but this relation between diagonal side of a square is used very rarely, so you may forget this. Okay, no problem. If you forget, we can use the formula a square equal to half d square. Okay, this is also area, this is also area. Area will not change. Okay, from this we can find the side of the square. A square is equal to 1 by 2 into d square is 2 to 5. Do not take decimal, you will face problem. Okay, a is equal to 2 to 5 by 2 square root. Square root of 2 to 5 by 2. Okay, the square root of 2 to 5 is 15 by root 2. So a is equal to 15 by root 2. Okay, now we can go for perimeter. Okay, although we can rationalize the denominator. Okay, here we can multiply root 2 by root 2 in order to rationalize the denominator. Okay, then we can easily find the side of the square. But we have not been asked to find side of the square, rather we have been asked to find perimeter of the square. So why to waste time here? Okay, don't waste time here. Perimeter is equal to 4 into side, you know this formula. So that is equal to 4 into 15 by root 2. 4 into 15 by root 2. Now rationalize. Okay. Now rationalize. 4 into 15 into root 2 value is 1.414. Means approximate value. Root 2 is an irrational number. Its exact value cannot be determined. Okay, this is the approximate value of root 2 nearest to 3 decimal place. Okay, by root 2 into root 2 is 2. Okay, you know this in the first chapter. Okay, rationalization. So this is 2 into 2 4, 30 into 15 into 2 is 30. Okay, 1414 by 1000. While calculating, I always convert to fraction because I am not comfortable with decimal. Okay, most people are not comfortable with decimal. That means addition, subtraction, or multiplication, division, basic operations. With decimals, it is a little complicated. Okay, I am also not comfortable, so I converted the decimal into fraction. 0 0 cancel. Okay, now multiply 3 and 1 4 1 4. 12 4 12 4. 4 to 4 2 by 100 means 42.42 meter. Okay, the perimeter of the square nearest to 2 decimal place is 42.42 meter. Okay, so you see this method. Okay, means I converted the decimal into fraction. So while multiplying, I do not need even a rough place. Then and there only I can multiply. Okay, so you try to use this method, always avoid decimal. Okay, so this is the perimeter of the square. Draw. Now let us move to question number question number 16. Okay, question number 16. measures 15 meter by 8 meter. Sorry, L is equal to 50 meter, B is equal to 8 meter. Is to be laid with tiles. Is to be covered with tiles. Measuring 50 cm. Length is 50 cm. Breadth is 25 cm. These are not square tiles. These are rectangular tiles. So the whole floor has to be covered with these tiles. You have to find the number of tiles required. Okay. So the formula will be n into area of each tile is equal to, let us not use this method, let us find area of each tile and area of the floor. Okay, area of floor is equal to 15 into 8, that is 120 square meter. Okay, area of the floor to be covered with tiles is 120 square meter. But you can see length and breadth of the tiles means are given in cm. So either you have to convert that cm into meter or meter into cm. If you convert cm into meter, then you will get fraction. You have to divide. Okay, so better you convert meter into cm. So 120, 1 square meter is equal to 10,000 square cm. In the previous or 1 or 2 questions back, we have done this. Okay, into 1, 2, 3, 4 square cm. Okay, 10,000 square cm. So 1, 2, 0, 1, 2, 3, 4 square cm. If we put comma, 1,200,000 square cm. This is the area of the floor in square cm. Okay, first we got in square meter, but we need square cm, so I converted. Now let us find area of each tile. Area of each tile is equal to 50 into 25. 50 into 25. 1250 square cm. Okay. So this is the area to be covered. This is the area of each tile. The number of tiles required will be this by this. Okay. Number of tiles is equal to 1250. Ready? So let us simplify this. Cancel. 25 5 is 125. This one will be 25 4 is 100. 200 means 8. 0 0. 4 is 0 by 5, which is 5 9 is 45. 5 6 is 30. 960. So total 960 tiles of that dimension, this dimension, will be required to cover the floor, that is this dimension. Okay. So this is the number of tiles. Next, the second part of the question. Further, if a carpet is laid on the floor, okay, if a carpet is laid on the floor, so that a space of 1 meter exists between its edges. Okay. Same question. Question is not over. Suppose this is the floor. Okay. This is the floor. Its dimensions are 15 meter by 8 meter. 15 meter, and this is 8 meter. A carpet has to, again a rectangular carpet has to be laid inside the floor, means on the floor inside the room, like this. Okay. Now this is the carpet. Okay, this is the carpet. This is the carpet, and this gap is 1 meter. Uniform gap is 1 meter. This gap has to be maintained. So we have been asked to find what fraction of the floor is left uncovered? Okay, uncovered means this part, the unshaded part. Okay, it is just like footpath problem. Okay, you have solved this. When the footpath is outside plus, when the footpath is inside minus. So this is similar to footpath problem. So area of means uncovered area. Okay, uncovered area. Okay, this is covered area, the shaded part. Uncovered area is equal to 2x l plus b minus 2x. I have given this formula and I have told that if the path is outside the rectangle then plus, if the path is inside the rectangle then minus. Here you can see the path is, or the uncovered area similar to footpath, is inside the rectangle, so minus. Okay, see, inside outside they look same. Okay, inside outside they look same. Suppose what you have to understand the difference. Okay, you have to understand the difference. Okay, see this one and see this one. Okay, they look completely same. Here also there are two rectangles, here also there are two rectangles, but there is a little difference. Here the outside rectangle dimensions are 15 and 8 and the path is inside the rectangle. You can see here the dimensions of the internal rectangle are 15 meter by 8 meter and the path is covering the rectangle, means outside the rectangle. Okay, so these two look same but they are not same. Here the path is inside, here the path is outside. For here minus as I have used here plus. Okay, let us put value. 2 into x means 2 into 1, that is 2. L 15 V8 minus 2. So 21. This is 21. 15 plus 8 minus 2 is 21. That is 42 square meter. Okay, how much? 42 square meter. So uncovered area will be 42 square meter. And we are going to find a fraction. Okay, means fraction of uncovered area. So let us find this. Required fraction of uncovered area is equal to 42 square meter is uncovered. Okay, and total area of the floor was I think 120 square meter. 120. Okay, so 42 by 120 means 7 by 20. Okay, so fraction of the uncovered area is equal to 7 by 20. Clear? Next, two adjacent sides. Question number 17. Question number 17. Two adjacent sides of a parallelogram are 24 cm, 18 cm. Okay. So let us draw a parallelogram roughly. This is a parallelogram. This is parallel. Adjacent sides are 24 and 18. Okay. The distance between the longer sides. This is how much? 12 cm. Okay, this is 12 cm. Find the distance between the shorter sides. Means this distance between the shorter sides. Okay. Let it be h2. This is h1. Okay, this is h1. This is h2. This is b1. This is b2. Okay, there can be two bases of the parallelogram. If you want, you can take this as the base, this is the height. If you want, you can take this as the base and this S2 as the height. Okay. So area is equal to B into H, base into height for a parallelogram. Okay. And that area will not change. That means B1 into H1 is equal to B2 into H2. Area of a parallelogram will not change. Area of the figure doesn't change. Okay. So the area of this parallelogram can be found from B1 H1 or from B2 H2. So we got an equation. B1 is 24, H1 is 12, B2 is 18, H2 we have to find. Okay, H2 we have to find. So H2 is equal to 24 into 8, 24 into 12 by 18. 6 into 2, 12, 6 to 18, 3 into 24, 8 to 16. So the distance between the other two parallel sides, means the shorter sides, is 16 cm. Okay. Now move to question number 19. 19. Okay. 19. The area of the rhombus is 216 square cm. Okay. If it's one diagonal is 24 cm. Ready. Okay. Now D1 is equal to 24 cm. Okay. D2 is not given. Okay. D2 is not given. Side also not given. Okay. But area is given. Okay. Area is given. Area into 216 square cm. Okay. First we have to find diagonal, then side, then perimeter. Okay. Unless we get side, we cannot find perimeter. So first let us go for diagonal. Now see, area of the rhombus is half into D1 into D2. Okay, because diagonals of rhombus are perpendicular to each other. So I put the formula 1 by 2 into what is D1? 24. D2 I don't know. Area is 216. Area is 216. Okay, correct. So 2 into 12, 24. D2 is 216 by 12, which is 12 under 12, 96, 18 cm. Okay, the other diagonal is 18 cm. The other diagonal is 18 cm. Okay. The other diagonal is 18 cm. Now let us go for side of the rhombus. Now how to find side of the rhombus? I had actually forgotten in part 3 to give the relation between two diagonals and one side of a rhombus. I forgot. Okay, I gave relation between diagonal and side of a square. Okay, but I forgot to give the relation between diagonal and side of a rhombus. So now I am giving. Suppose this is a rhombus. Okay. This is a rhombus. All the sides are equal. A. Okay. Let us join the opposite vertices to get the diagonals. Get the diagonals. We know the diagonals are perpendicular to each other. Suppose this is diagonal D1. This is D1. Okay, this is D1. So this will be D1 by 2. Because diagonals of a rhombus bisect each other. This we have studied in rectilinear figures. Okay. Suppose this is D2, the other diagonal. This will be D2 by 2. So this is D1 by 2, this is D2 by 2, and this is A. Suppose this is P, Q, R, S, this point is O. You can see this triangle is right angle. Triangle POQ is right angle. Okay, so we can use Pythagoras theorem here. So PQ square is equal to OP square plus OQ square. This is Pythagoras theorem. PQ is the hypotenuse. As you can see, it is opposite to right angle. So A square is equal to d1 by 2 whole square plus d2 by 2 whole square. So this is the relation between side of the rhombus and its diagonals. Okay, and its diagonal. This is the relation. So let us put value and find the side. A square is equal to d1 by 2 means 24 by 2, which is 12. d2 by 2 means 18 by 2, which is 9. Okay. A square is equal to, this is 144, this is 81. A square is equal to 225. A is equal to 50 centimeter. So side of the rhombus is 15 cm. Okay, we got the side. Now we can easily find the perimeter. Perimeter is equal to 4 into side. Okay, so 4 into 15 is equal to 60 cm. 60 cm. This is the perimeter of the rhombus. Okay. Move to question number 26. Question number 26. Question number 26. Okay. A wire when bent in the form of a square. Question number 26. A wire when bent in the form of a square. Okay. What are diagram I am making? This is a square and this area is 484 square meter. Okay. Now the same wire will be bent to form an equilateral triangle and we have to find its area. Again the same wire will be bent to form a rectangle whose breadth is 16 meter, second meter, and we have to find its area. Okay. First let us find the length of the wire. Okay, that is very important. Without length of the wire we cannot do anything. Okay. So remember, when you get wire problem, okay, when you get wire problem from this chapter, the most important part is to find the length of the wire. Okay. So now what is the length of the wire? Perimeter of this figure. Okay. And how to find perimeter of this figure? First we find side of this square. This is the square. Okay. So A square is equal to 484 square meter. A is equal to square root of 484, that is 22. Yes, 22 meter. Square meter. Okay. So side of the square is 22 meter. Perimeter is equal to 480. Since it is square 4 into 22, that is 88 meter. And this is the length of wire. Okay, length of wire. Okay, 484, 22. Okay. Okay. Ready. Okay, perimeter is 88 meter. Also, this is the length of the wire. So, successfully we got length of the wire. Now, you can find anything. Now, let us make the first bit 88 meter. Remember the value 88 meter. Okay. First bit, we need to find area of the equilateral triangle. Okay. A. Okay. The length of wire will not change. That means the perimeter of the figures will not change. You may form a square, you may form an equilateral triangle, you may form a rectangle, you may form a rhombus, parallelogram, trapezium, anything with the help of a square. Means with the help of a wire. Sorry, with the help of a wire, The length of wire is not going to change. That means the perimeter is not going to change. Okay. So here 3A is 88 meter. Length of wire will not change. Perimeter will not change. So A is equal to 88 by 3 meter. Okay. 88 by 3 meter. 21 square 441. 22 484. Okay. A is 88 by 3 meter. So area is equal to root 3 A square by 4. You know this formula. Okay. In part 1 I am given root 3 A square by 4 for equilateral triangle. So that is root 3 by 4 into A means 88 by 3 by 3 whole square. Okay. So that is equal to 1.732. Approximate value of root 3 is 1.732. You have to remember. Root 2 and root 3 value at least you have to remember. Okay. So 1.732 by 4 into 88 into 88 by 3 square is 9. Okay. 3 square is 9. Okay. So what to do now? 4 into 2, 2. Ready? 4 into 2, 2. 88 meter. Now 1732 into 88 into 22 by this is 1000. This is 9. Let us not disturb this 1000. It is very helpful. Okay. Let us multiply this and divide by 9. Multiply this and divide by 9. 1732 into 88 into 22 divided by 9000, which is 372.572444. It is continuing. I am keeping it to 2 decimal place. Okay. This is square meter solution. So area of the equilateral triangle formed by the same wire is 372.57 square meter. Clear? Now let us move to rectangle. Triangle is over. Now let us move to rectangle. Some question. Second bit. Length of wire will not change. That is 88 meter will not change. Length of means the perimeter of a rectangle will also be 88 meter. Okay. 2 whole L plus B is perimeter. Okay, rectangle. Okay. 2 whole length is given, not given. Breadth is given 16. Perimeter is 88. Length of wire will not change. So L plus 16 is 22. 44. So 44. Okay. L is equal to 44 minus 16, which is 28 meter. Okay. So this is the length and this is the breadth. We can easily find the area. Area is equal to L into B. 28 into 16, which is 480 minus 32, 450, 448. Okay, so area of the rectangle whose breadth is 16 meter for the same wire is 448 square meters. Okay, you can see area is changing. The area of the square was 484 square meter. The area of the triangle became 300 something. Okay, I don't remember, 300 something. The area of the rectangle became 448 square meter. So area is changing, but perimeter will never change. Remember this trick for wire problem. Perimeter doesn't change because length of wire doesn't change. Ready? Next, Next, move to question number uh, 30. Okay, 30. The length of a rectangle is twice the side of a square. Side of square not given. And its width is 6 cm greater than the side of the square. Okay. So let us start from the square. Let side of square be x cm. You can take a cm also, no problem. You can take any variable y, a, b, etc. Okay. Length of the rectangle is twice. Okay, means 2x. Breadth of the rectangle is 6 cm greater. Okay, means x plus 6 cm. And what is given? The relation between area of rectangle and square is given. Okay, so area of rectangle means LB is equal to 3 times the area of square, 3a square. This is given. Okay, so let us put value 2x whole into x plus 6 then into breadth is equal to 3a square. A is x, 3x square. Ready? 2x square plus 12x is equal to 2x square plus 12x is equal to 3x square. Ready? 0 is equal to x square minus 12x. Take everything to the right. Okay. So this is x common, x minus 12 is 0. So x is equal to 0 or x minus 12 is 0. X is 0 is not possible. Okay. How the side of a square is 0? If it is 0 means the square doesn't exist. Okay. This is discarded. Not possible. Discarded. X is 12. This is possible. Okay. So what you have to find? Find the dimensions of each. Okay. Side of square is equal to 12 cm. Okay. 12 will form. Okay. Then length is equal to, means length of rectangle is 2 times, I think. So 2 into 12, that is 24 cm. Breadth is equal to x plus 6, that is 18 cm. Okay. Now let us move to our last question. Question number 36, the last question. Okay. 36. The diagonal of a rectangular plot is 34 meter and its perimeter is 92 meter. Okay. Let us draw a figure. Draw a rectangle. So this is the diagonal. This is the diagonal, and this is given 34 meter. Okay. This is given 34 meter. This is length, this is breadth. Okay. This is rectangle. This is a rectangle. So perimeter is given. Means 2 whole L plus B is 92. Okay. 2 whole L plus B is perimeter 92 given. Okay. So L plus B is equal to 46. Okay. L plus B is equal to 46 meters. Okay. Let L is equal to x. Okay. Let length is equal to x. If length is x, breadth will be 46 minus x. This will be 46 minus x. Length is x, breadth is 46 minus x. Okay. This is 46 minus x. This is x, this is 46 46 minus x. So let us find, we have to find its area. For that we need its length and breadth, and for that we need x. Okay, first we find x, then only you can find the length and breadth, then only you can find area of this rectangle. How to find x? We can use Pythagoras theorem here. X square plus 46 minus x whole square is equal to 34 square. See, it is a rectangle. This is the hypotenuse. This is base. This is perpendicular. Okay, you can use Pythagoras theorem here. 46 square is 36, 3. 46 plus 6, 52 into 4. 50 into 4, 208, 211. 211 plus x square minus 92x is equal to 34 square is 4 square is 61. 34 plus 4 is 38 into 3. 120, 114, 115. 115. Okay. So x square plus x square is 2x square minus 92x. 2116 minus 1156 is equal to 1156 is outside. 2116 minus 1156 is equal to 6 minus 6 is 0. 1 minus 5 not plus 11 minus 5 6. It becomes 0. 10 minus 1 is 9. 960. Let us check. 6. Correct. Okay. 0. So this is a quadratic equation here. Further it can be simplified because 2 can be taken from. So x square minus 46x plus 480 is 0. Clearly this is a quadratic equation. Okay. Ready. How to solve this? Product is positive means we have to take sum. 20 into 24. 1630. Yes, 1630. 16 3 are 48. 16 and 30 we can take. 16 and 30. Okay. Okay, this is the factorizing. Next, x whole x minus 16 minus 30 whole x minus 16 is 0. X minus 16. Okay. X minus 16 is equal to 0. As you solve the quadratic equation, in that way I am solving. Okay. X is equal to 16 or x is equal to 30. Ready? You can take any value. Okay. You can take any value. Suppose x is 30. You can take any value. Okay. 30. If x is 30, 46 minus x will be 46 minus 30, that is 16. Okay, why I told that you can take any value? Because see, if you take 16 here, means if you take this one, you will get 16 and 30. Length is 16, breadth is 30. That is correct, no problem. If you take 30, you will get 30 and 16. Length is 30, breadth is 16. Again the same thing. Okay. Do not assume that or do not conclude that in a rectangle the length will always be greater. Okay. One side is named as length, the other side is named as breadth. That doesn't mean that length is greater and breadth is smaller. Okay. Sometimes length can be smaller, breadth can be greater. Okay. So you got the dimensions. Now we are required to find the area of the rectangle. area into length into breadth. 50 into 60. 16 to the 40, 48, 0. Oh, this is meter. This is meter. So area of the rectangular plot, this is a rectangular plot, okay, is 480 square meter. Clear? So these are some examples which I have solved related to quadrilaterals, area and perimeter. I hope you have understood this part. Okay. In the next part, I will go for area and perimeter of circles. Okay. So thank you for watching.